Hello class, and welcome to Notes 7.G.4, Perimeter of Composite Figures. Now our standard, we're continuing that same standard, and we're covering the portion as know the formulas for area and circumference of a circle and use them to solve problems. And you're in luck, we only have one vocabulary word for today, and that is a composite figure. It's a figure made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. Here are two examples that I have for you. So in this first one you can see we've got a square right next to a triangle. In the second one we have a semicircle, which we already know is half of a circle, and a rectangle. So today what you're going to be doing is finding the perimeter of these shapes. What you're going to have to be careful of is watching out for these dotted lines. Keep in mind these dotted lines you're not including in your perimeter. So the perimeter is just the outside, not anything inside. So let's go ahead and take a look at our teacher example 1. We're going to estimate the perimeter of the arrow. So we have this picture right here. Here's our arrow. And we're going to start by coming over and looking at this picture. So it says count the number of grid square lengths around the arrow. There are 20. So right here in red you can see we've counted 1, 2, 3, and so on, all the way around here in red, and we get 20. Now we count the number of diagonal lengths around the arrow. There are 8. And notice it says estimate the diagonal length to be about 1.5 units, because this diagonal length here is longer than the sides of the square. So each of these here are longer than regular sides. So we need to go ahead and add those together. We have first the length of 20 grid squares lengths times 1, because each of them just represents 1 unit, is 20 units. Now for the blue portion of the arrow, notice they were each 1.5. So we do 8 times 1.5 and we get 12 units. So we've got the red portion has a perimeter of 20, the blue portion has a perimeter of 12, and putting them together, so the perimeter is about 20 plus 12, which would make it 32 units. Notice we do need our units, but since we don't know if it's centimeters or inches or what it is, we just simply use the word units. When you do get to this student example, I want you to remember that the diagonals are always 1.5 units. You do also want to make sure you write that down, because that will be on your quiz as well. Okay, so let's go ahead and get to our student practice. Go ahead and estimate the perimeter of these figures. Remember the straight sides are each 1 unit, the diagonals are each 1.5. Go ahead and press pause and press play when you're ready to see the results. Okay, welcome back. We go ahead and we count through these. We count these sides, we count these sides, multiply each of those by 1, count these here, and these here, and multiply each of those by 1.5. On this one's a little simpler because most of them are just solid lines. You just have this one set of diagonals here. So you can go ahead and add them all up, and you'll find that image 1 is about 32 units when you count all the way around. And image 2 is about 33.5 units. You have that extra half. Okay. Let's go ahead and go on to teacher example 2. The figure is made up of a semicircle and a triangle. Find the perimeter. So here we have a semicircle and we have a triangle. One thing you do want to watch out for is the semicircle, normally you add the diameter in when you're finding your final answer, but because this is in the middle of the shape, it's not part of the perimeter. Same thing with a triangle. If you're finding the perimeter around the triangle, you would add that 10 in, but since we want to go all the way around the whole shape, we're going to ignore that 10. So the distance around the triangular part of the figure is 6 plus 8, which is 14 feet. So we're just doing these outside legs. The distance around the semicircle is 1/2 of the circumference of a circle with a diameter of 10 feet. So of course we would do pi d, find what that is, and then cut it in half. Okay, so we end up with an answer of 15 7/10. Now we can simply add that to our 14, and we have a final answer of 29 7/10 feet. Notice I have included my units here, And I do have my answer. It does go into the tenths place, so I want to make sure I watch out for that decimal. When you're doing these problems on your own, make sure you're careful with the decimal. Always round to the nearest hundredth unless it says otherwise. Okay, teacher example 3. The running track is made up of a rectangle and 2 semicircles. Find the perimeter. So, first, the semicircle ends of the track form a circle with a radius of 32 meters. So here's 1/2, and here's 1/2. If I put just those two end pieces together, I'll end up with one giant circle. And notice I've got my radius right here. So all I need to do is find the perimeter of that circle first. C equals 2 pi r. Plug my numbers in. 2, obviously. 3.14 I'm using for pi, and then my radius of 32 meters I can plug in here. Now I can do my multiplication, and I end up with 296 hundredths. This is not, however, the perimeter of the entire track. It is only the perimeter of the two circles. We need to also include this rectangular portion. Now notice we have this rectangular piece, or this length right here, which we know is 100 meters. So if we come over here, we also need this length, which will obviously also be 100 meters. So I need to add each of those pieces of the rectangle. Notice I don't need to include this portion of the rectangle, the width, because it's not part of the outside perimeter. So the perimeter is about 100 plus 100 plus 296 hundredths, which makes 496 hundredths meters. Notice I have gone to the hundredths place. Make sure you also take yours out to the nearest hundredth. Okay, so go ahead and do these two problems. Remember, watch out for the dotted lines. Those are not part of the perimeter. Go ahead and press play when you're ready to see your results. Okay, welcome back. Let's see how you did. Here we have a semicircle with a diameter of 26 centimeters. So on this problem here, you are doing C equals pi d, and then cutting it in half or dividing it by 2. Then we add on the 10 and the 24 to get our final total of the entire shape. Number 4 looks just like the track. Notice it says it's a square. So this might have thrown you a little bit. You might have felt like you didn't have enough information. But keep in mind you have the diameter of the circle, because on a square this side is 8 meters. This side here must also be 8 meters. And this side and this side. So we do have the diameter of our square, right, or of our circle is 8 meters. So I can do C equals pi d. And notice I don't have to cut it in half because I have half the circle here and the other half here. So I can go ahead and multiply 8 times pi. When I have my answer, I can add the 8 from this side of the square and the 8 from this side of the square. And when I take a look, I have number 3 about 74 and 82 hundredths centimeters, and number 4 about 41 and 12 hundredths meters. Notice on both of these we will use the word about, and that is because we were working with pi, so we have done some rounding. Okay, this was a very short video. Hopefully you understood those composite figures, finding those shapes, just putting them together. Now you can go on to the quiz and have a great day.